Hello, students. Welcome back to another anticipated Calculus 3 review video. I am joined by my co-host, Soloist.
Wow.
Now, would you introduce yourself professionally?
Okay, my name is Soloist, and I'll be going over the second example problem for Calculus 3, which will prepare you for your final exams, which are coming up.
Yes, and I'll be going over number one on this sheet. Okay, so first of all, number one asks, find the volume of the 3D shape created when the function y equals x is revolved around the x-axis while also being restricted by the line x equals 3 and x equals 0. So there's always a step-by-step process on how to solve a problem like this. So first of all, what you want to do is draw the graph of y equals x. So don't mind my bad drawing. It's just a little. It'll do its work. It'll do the. Oh, that kind of looks a little bad, but it'll do its job. So this is the function y equals x. So now it says while also being restricted by the line x equals 3 and x equals 0. Let's go draw those in. So x equals 0 is just the y-axis, and let's like do some tick marks here. 1, 2, 3, and let's pretend that this is x equals 3. So what we have here is this question is supposed to say and y equals 0. Yeah. So this is being restricted by the y equals 0 line 2, which is the x-axis. So just that. So now we have created a triangular shape. Let's shade that in. So once we shade this shape in, that's the area under the curve of y equals x from x equals 0 to x equals 3. You want the volume when you rotate it around the x-axis. So to do this, it's basically like flipping the shape over. So we want to create a cross-sectional area here, like that. It's like a conal shape. It's like a cone shape. So you got that, right? So there are two ways to do this. You can either do it the cylindrical way or this cross-sectional way. So the formula for this, the cross-sectional way is pi times the integral of, since we're doing it with respect to the x, since we're rotating on the x-axis, we're going to be doing in x terms. So it would be f of x squared from a to b. Oh, is it from b to a or a to b? Yeah, a to b.
A to B.
Dx. So this is the general formula if you're rotating around the x-axis. If it said y-axis, you would change this to a dy and you would do g of y instead. But this is the general formula. So our f of x in this case is x. So we're going to plug in. Also, our bounds are 0 to 3. 0 to 3 of x squared dx. And this is a simple integral. All you guys should know to do this. If you don't do this, you're stupid. But you guys are not because I trust my viewers. To solve this out. Oh, I forgot to say v. Don't forget your v's, right? The volume is equal to this. Wait, let me make that volume look a little better. Volume is equal to this. Volume is equal to this. Volume is equal to that. And then this is equal to, so 3 to the power 3 is 27 divided by 3, 9, and 0, who cares about the 0? 9 pi units cubed, and that is your final answer for this question. So now we'll be moving on to Soloist going over his question now.
Okay, my question is a very simple mean value theorem question. The question is asking for the value of c on the interval from 3 to 9 that is guaranteed for the function 3x squared minus 2x plus 3. So first of all, we need to take the derivative of this. So this will become f of f prime of 6x minus 2. Now, we need to take the antiderivative of this. Now, if you don't know what an antiderivative is, it's basically f minus x. And this would basically convert the question into 6x minus 2 raised to the power of negative 1/2. Now, why do we do this? This is because right now f(3x squared minus 2x plus 3) has an unlimited interval. It exists from negative infinity to positive infinity. We need to make it so that it only exists on from 3 to 9. So by doing this, we then get, I'm not gonna write out the f minus x part, it's really annoying, but we get 1 divided by, or 1 over the square root of 6x minus 2, and we then take the derivative of this. Because it's a square root, the square root actually cancels out, and we just get 1. This is the slope of the equation, so then f of x would equal 1. This is the first value we could get, but then we need to plug in f of 3, which then would give 1 plus 3, and that's 4. We do the same for the next, or the last interval, which is 9, and that gives 1 plus 9. Now, for this might be a little complex, so we need to draw out a table. So this would be 9, and then we need to carry the 1, so because it equals 10, we put 1 up here, and then this becomes 0, and at the end we get 10. These are the two values. Now, we must draw a graph. We'll draw it right here. Because f of 3 equals 4, we get this point right here, which is 3, 4, and we get this point right here, which is 9, 10. Thank you, Cookie, for helping me with this graph. If we draw the slope of this, we find out that there's a hole in the graph. This hole, if we take a derivative of it, gives us 3x squared plus 2. If we take the third derivative, or second derivative of this, we get 6x. Take the third derivative, we get 6. And that, which right here, is the final value of c that would exist on the interval between 3 to 9.
So thank you for listening to our 2 Calculus 3 review questions, and we hope that you score 100 on that test. So Souls, do you have any parting words to say to our wonderful viewers?
I would recommend our viewers to also buy the course that's in our description. It costs roughly $100, but it's been certified by over 200 reviewers to have helped them pass their final exams and graduate college. So highly recommended that you purchase this, as it could be an amazing investment for your college pathway.
Yes. And now we thank you for listening to this video, and we will see you next time.
Peace, guys.
Bye.